Hi, Bob Wilkins here again. In this video I will describe how to use a small inexpensive circuit board that you can set up on a small single track oval or circle layout that runs automatically with an adjustable stop time. This setup is most commonly used to simulate a station stop. After a pause, the train continues to repeat the process. The components needed to complete this project, in addition to the track for the layout and a train controller transformer to run the trains, includes first the automatic stop and go relay circuit board, a reed switch that is set into the track and is activated by a magnet, a neodymium magnet that is attached to the train, and a power pack, either a 9-volt battery or 9 to 12-volt DC power supply. In addition, a piece of track that is modified to accommodate the circuit. I will call this the stop track. Some connection wires for the track, relay board and reed switch, preferably double-stranded 26 to 28 gauge wire, will also be needed. Automatic control of the stopping operation is via the stop-go relay board. The components of this board include the blue connection plugs that connect wires to the 9-volt DC power source, to and from the reed switch. Here the ground wire is connected to the negative terminal, and finally to and from the track, as we will describe later. The relay switch is activated by the reed switch. The timer chip establishes the stop time delay for the train. A potentiometer sets the stop time, which can be varied from 1 to 60 seconds. A green LED that turns on during the delay time. The stop and go relay board setup is shown here. I will step through each connection as follows. The variable 12-volt DC output from the train controller is attached to the track and controls the train speed. The positive wire is set to the same side as the rail gaps shown here. Here the board is powered by a connection to a 9-volt battery with a switch to turn power on and off. A 9 to 12-volt DC power pack wall unit can also be used. The connections for the positive wire and the ground wire are indicated on the board. The reed switch is set in the track before the stopping point. The reed switch is activated by the neodymium magnet that is placed on the undercarriage of the locomotive. It is usually attached to a screw or other metal part under the locomotive. The reed switch activates the relay, which turns power off to the isolated section of the stop track. Once the locomotive's electrical pickup crosses into the section of this track, the locomotive will stop. The timer chip activates for a delay period that is set by the adjustable potentiometer. Turning the clockwise increases the stopping time. When the pause time expires, the relay is turned off, repowering the stop track, and the train resumes forward motion. This system can be set up typically at a station stop to simulate a train stopping for passengers. In setting up this circuit, you need to first determine where to locate the activating reed switch. Generally, this is set just before the train crosses into the isolation stop track. In HO scale, this is around 12 to 24 inches from the first gap in the stop track. The two ends of the reed switch are soldered to connection wires. The wires are fed through the track between the ties so that the body of the reed switch can be laid parallel to the track rails. The wires are run under the rails and are connected to the terminals on the circuit board labelled IN and G. The orientation of these wires does not matter. Next is where to locate the isolation stop track. This should be placed so that when the train stops, most or all of the passenger cars can access the station's platform. This point will generally put the isolated part of the track at the far end of the station or just beyond. Last is how to build the stop track. 2 brake gaps are needed in the track. The spacing between these gaps will depend on the length of the locomotive's electrical pickup wheels on that side of the stop track. Select a piece of track, cut the gaps using a fine hacksaw or Dremel type cutting disc, or use smaller pieces of track with plastic insulator joiners to isolate the track. The cut gap should be just wide enough to break the electrical contact. Feeder wires are soldered to either side of the furthest track gap and are connected to the circuit board. Connect the wire from the section of track between the gaps to the port labelled NC, normally closed, and the other wire to the main track to the middle common port. The NO port has no connection. An interconnecting bypass wire that takes electrical current around the gaps is now installed. This wire can be prepared by soldering the wires directly to the track beyond both gaps, or solder the wire ends to 2 rail joiners and insert at the rail junctions. Here the joiners are attached to the ends of the track that contain the gaps. The stop track is now installed on the layout. The unit is now ready for testing. When power is applied, nothing will happen until the locomotive with the magnet attached passes over the reed switch. This will activate the relay delay. The green LED on the board will light. The locomotive will stop on the stop track and wait for the timer chip to count down. You can adjust the time delay by turning the potentiometer dial using a small flat-bladed screwdriver. Turn it clockwise to increase the delay and counterclockwise to shorten it. Once the delay has elapsed, the green LED turns off, the track is switched on, and the train proceeds forward. All of these instructions are available at the website modeltrainsounds.com in colour and downloadable format. They are listed under Project 17. A kit that enables you to try this project is also available. The kit contains the automatic stop-and-go relay board along with a reed switch, neodymium magnet for the locomotive. These magnets can be found at most hardware stores or online. Keep them away from small children that may accidentally swallow them. A 9-volt battery holder with a switch is provided for the power supply to the board. As always, thanks again for watching, and remember to subscribe and watch for more updates and projects.